Within the ion worksheet, we need to understand how to name ions and how to know whether something's going to be a cation or anion and how many electrons it's going to gain or lose to become a stable ion, when compared to the atom, of course. So remember, an ion is going to be an atom that gains a charge. So atom with a charge. Make that a bit smaller. Okay, so we're going to go through some of the more common ones. So a positive ion. Well, this ion's name is going to be, since it's positive, we know it's just going to be something ion. And Na, when we look up in the periodic table, is sodium. So we know the name is sodium ion. Now, is it a cation or an anion? Well, since it's positive, we know it's a cation. And cations, what happens? Well, they need to lose electrons because they're going to become positive. So it's going to have less electrons than the atom. And how many less? Well, in this one in particular, we see it's a +1, right? If it's just plus or negative, that's going to equal to 1. If it was, say, plus or -2, then it's going to have 2. So how many did it lose or gain? Well, it's going to lose 1 electron. And that's answering sodium. Now, on the flip side, chlorine, we know is a negative, because we know when we look at the periodic table, it's on the right side of the periodic table. Also, because it has IDE at the end, we know it's going to be a negative ion. So when we find chlorine on the periodic table, we know it's in group number 7, which means it has 7 valence electrons. And in fact, if we draw chlorine out, chlorine, the Lewis structure is going to be north, south, east, west, north, south, east. So it's going to have 7 valence electrons, meaning it's going to gain 1. So we would write this as Cl negative. Remember, it's just negative, it's not -1 because we don't write the 1. Is it a cation or an anion? It is an anion because it's going to gain an electron. It's going to have a negative charge, and negative charges are anion. Does it have more or less electrons than the atom? Well, it's going to have more electrons than the atom because it's going to gain 1. And then we would say it's going to gain 1. Aluminum, since it's just pronounced aluminum fully, we know it's going to be a positive. Okay, so that's where the positive is going to come in. Now, we get a little bit trickier when we talk about multivalent. So a good example of a multivalent is this one, ferric or iron 3 iron. We call it ferric. That's going to be the name when it's iron 3, but we're just going to refer to iron 3. We know all our multivalents are going to be positive. And if we look up iron on the periodic table, iron is Fe. Now, since it's 3, and we know that they're all going to be positive, we're going to say Fe3 plus. Now, it's going to be a positive, so it's a cation. A cation is going to lose, so it's going to have less electrons. And how many? Well, it's going to lose 3, because it says right there. So we're going to lose 3 electrons. Now, similarly for the copper, so the copper, the Cu, that's copper, right? We look it up on the periodic table. We know it's a positive because all our multivalents are going to be positive, and they're going to be just written as the name and then ion. But since copper is a multivalent, because we get told that on our chart, we're going to write copper, and the charge on this one is 2. So we would write copper 2. Now, we talked about before that most of our multivalents are going to fall in that transition metal area of the periodic table, or we're going to be told about it. Copper is a transition metal, copper is a multivalent, and therefore it's going to have that charge of 2 in this case. But like in the next one, where it's copper 1, that's the difference between copper 1 and copper 2. Okay, sometimes it can have 1 charge, and sometimes it can have a charge of 2. So in this case, copper 1, we're going to write Cu because that's the copper. Since it's just 1, we're going to write 1. It is also a cation. It's going to have less, and it's going to lose, in this case, 1. Sorry, in this case, I was looking at the wrong slide here. So in this case, it's actually going to lose 2. And in the bottom case, it's going to be the same, copper, less, but in this case, it's going to lose 1. Now, everything else is pretty straightforward. Nickel is another transition. We know that because of the Roman numeral, that we have right there. The only other tricky one might be this oxide ion. Again, since it says "ide" at the end, we know it's going to be a negative. So we write O 2 negative because of where it is on the periodic table. When we look on the periodic table, oxygen, I'm just going to draw it right here, has 6 valence electrons. So it's going to be 1, 2, 3, 4, 5, 6. So in this case, it's going to be an anion because it's going to gain. So it's going to have more. How many more? Well, it has 2 more. So it's going to gain 2. And that's it for the ion worksheet.